What's up, everyone? This is LeetCode 207 course schedule. We're doing this in C++. We've done this problem in Python, right? So we have a total of num courses that we have to take, labeled from 0 up to and including num courses -1, right? For example, if num course is 2, right, we have basically course 0 and 1 to take. And then we have an array of prerequisites such that we have a pair, right, A1 and B1. And what this means is that we have to take course B1 before we can take course A1. So B1 would be the prerequisite for course A1, right? So for example, this pair here, to take course 0, we first have to take course 1, okay? And we have to return true if we can take all courses. Otherwise, we have to return false. Now, why would we return false? Is because we could have cases where, you know, to take course 1, we have to take course 0, and to take course 0, we have to take course 1. That's not possible, obviously, right? Because how can you take one if they depend on the other? So that'd be a problem where we would return false, right? So I'm going to draw this out because visually it helps a lot to visualize this problem rather than rely simply on understanding the problem through text. Because they didn't provide any pictures, right, for the graph. So for example, this is example 1, right? To take course 1, we have to take course 0. So we'd return true in this case, right? This case is where we would return false because to take course 0, we have to take course 1. But to take course 1, we have to take course 0. Where would we even start, right? We can't start anywhere. This is not, we can't take these courses. So we'd return false in this case. Now, here's an example 3 that I made, right? And I'm going to show you how to solve this problem, okay? Using this example. So we're going to create a hash map, right? And we're gonna basically set up an adjacency list, right? So we're gonna have a given course as the key and the prerequisites as the values, okay, in the hash map. Now, generally, I think in adjacency list you use neighbors of a particular node, but we're not actually using neighbors. We're using the prerequisites, right? So, for example, when this 0 points to this 1 and 2, but these are not the prerequisites, right? Wherever the arrow is coming from, that's the prerequisite. So for this 2, the prerequisite is 0, right? So anyways, we set up our hash map like this, right? 0 has no prerequisites, 1 has a prerequisite of 0, 2 has a prerequisite of 0 as well, and 3 has prerequisite 1 and 2, okay? And I have this basically drawn out these steps here, or written out these steps to make it easier to understand how we're going to solve this, right? We're going to set up the adjacency list, right? The hash map, like what I did here for a particular problem. Then we're going to create 2 sets, right? A visited set and a process set. Now I'm going to try and explain, without getting too wordy, why we're going to use these sets, right? So let's say we have an example like this, right? Now we're going to have a visited set and a process set. So I'm going to explain the visited set first, okay? Now, the point of the visited set is that when we start at a particular course, let's say we start at the 0, we're going to put that into the visited set, right? And the point of the visited set is that if we encounter a node that's already in our visited set, we know we have a cycle. For example, let's say we have something like this, right? So initially we're going to start at the 0, right? So we're going to put that into, that's going to be in our visited set, okay? Does this 0 have any prerequisites? Yes, it has a prerequisite of 1, okay? And we're going to perform DFS, so when we go to this prerequisite of 1, does this 1 have a prerequisite? Yes, it has a prerequisite of 0, but 0 is already in our set. So we encountered it a second time, so we know that because it's already in our visited set, and we encountered the 0 for the second time, we know we have a cycle, so we can't actually take this course. So we would return false, right? So that's kind of the point of the visited set. Now, let me explain the point of the process set. The point of the process set is like, let's say we handle this 0. Does it have any prerequisites in this example? No, right? So after we're done processing a node, right? Like this 0, right? Does it have any prerequisites? No, it doesn't. So we remove this 0 from the visited set and we put it in the process set. Okay. Now let's move on to the next node. This 1. Okay, put this 1 in the visited set. What is the prerequisite of this 1? It's 0. Well, 0 is already in our process set. So what do? we can return true for the actual DFS call to this node here, because we don't actually have to do any checking because it's already we already processed it once before, right? So the point of the process set is basically to cut down on redundant work. Because let's say we have a bunch of nodes, right? When we're at this 1 and we go to this 0, do we really need to check all these prerequisites here for this 0? No, we don't, right? Because we would already have processed it. So it's basically to cut down on redundant work and to not do checks again, right? For the prerequisites for a particular node. So that's kind of the point of the process set. So I hope that makes sense. I honestly think I explained that a little better in this video than in the Python video, but hopefully that makes sense. Okay, so we're going to create those sets and we're going to use them, right? We're going to set up the hash map, and then we actually want to create the DFS function and check to see if we can take all the courses. And when I say DFS, we're really just doing like a reverse topological sort to basically detect if we have a cycle in our graph. That's really what we're doing. I think a topological sort is slightly different than what we're doing. Ours is kind of like a reverse topological sort, because we're not checking the neighbors of a node. We're checking we're basically checking not the neighbors of a particular node, like where it points to, but we're checking what's pointing to that node, because we're checking the prerequisites, right? So I think it's not exactly a topological sort. I think it's like a reverse topological sort, kind of. But anyways, it's kind of just getting into the weeds. So first of all, let's handle an edge case, okay? So we're going to say if prerequisites is empty initially, right, we can return true, right? Because if we have no prerequisites, then we shouldn't really have any problem with any of our courses anyways. That's just an edge case we have to handle, okay? Now let's set up our sets, okay? So we're going to say unordered set visited. Our nodes are actual integers, so that's why we're doing it like this. Processed. And of course, we have to create the hash map, right? Again, the course is the key, and then we have the prerequisites as an adjacency list. So we would have like a list for our values. We're going to say vector int course graph. Okay. We're just going to call our hash map course graph. So let's build the adjacency list. So we're gonna say for const auto, and we have the prereq, right? We're just gonna call it prereq. It's a little bit shorter. And we're gonna say course graph, right, for a particular course. Now remember, A1 is the actual course, B1 is the prereq, right? So this would be the course and this would be the prerequisite when we go through the prerequisite array, okay? So just keep that in mind. So because the course is the first one, we're going to say prereq of 0, right? That would be the key, right? The actual course. And then the value would be the actual prerequisite for that given course, which would be B1, right? So we're going to say pushback prereq 1, okay? And again, I know this might look a little strange, but it's just because we're just doing this because of the way basically the prerequisite array is set up, and how they kind of handle the logic of course versus prerequisite, okay? Okay, so here we're going to have the function actually, I mean, I guess I can define it outside. So we could say, I mean, you can use a lambda function, I guess, if you'd like. But we can just do ordered map. I mean, maybe a lambda function would be a little bit easier because this is a little bit messy, but I guess that's kind of C++, you know, that passing your references such. So let's say processed. Yeah, I mean, you can use a lambda function if you want. Like, this is kind of messy. That is, I will give you that. So we created the adjacency list. We set up the process nodes, or not the process nodes, the actual sets, right? So in here is basically, first of all, we're going to check if we're gonna basically check if the course is already visited, right? This would be basically cycle detection, like I said. If we run into a node for the second time, basically. So we would basically say if visited, not find course. This is a case where we want to return false in that case, right? Now here basically is the second part where we basically check if the course is already processed, meaning like we're in a recursion stack, right? And we go to a node and we already processed that node, we don't have to do it a second time, so we can just return true, right? So this is a case where we'd say if processed find course is processed end, right? And this is a case where we can just return true. Okay. Okay, so those are the two cases. Now, here is the case after if we don't enter any of those, then this is the part where we actually add the course to the visited set. Okay, we do that, and now here is the part below where we're going to basically check and run DFS on the actual prerequisites of the given course that we're on. Okay, so we're gonna say int prereq, right? We're gonna say course graph course, right? And here we're gonna say if DFS, and this is why I said maybe the lambda function is better because we're gonna have to pass it in a bunch of stuff. Like course graph visited, process. I'm just gonna put my. I'm gonna line up my braces just so it's a little bit easier to read. So yeah, basically we're gonna run DFS on the prerequisites of a given course that we're on. And as we do that, as we keep running DFS on the prerequisites, if we return false, it means we found a cycle at some point, and so we actually return false for the actual function call, right? As we exit. Okay, so after this, we have to remove this from the visited, the course that we're on, and we want to put it in processed. So we would do insert course, right? And we don't run any if we don't run into any problems, we can just return true. Okay. Now so that's basically our DFS function, right? Hopefully that makes sense, right? We're just checking if we have a cycle, if we already processed it, so we can reduce, right? This is to reduce redundancy. Redundancy. Okay. And then we run the actual DFS function on the prerequisites of a given course, right? And we're gonna return true or we're gonna return false. Kind of depends, right? Whether we have a cycle or not. Now we need to actually call this DFS function, and the way we're gonna do that is we're gonna basically go from num courses from 0 up to including num courses -1. Okay, so the way we're going to do that is after down here when we're done building the adjacency list, we're gonna say for int course 0 course less than num courses, right? Oops. We're going to basically run this. We're going to run the DFS function on basically all the courses from. So if there are two courses, right? We have course 0 and 1. We're going to run the DFS function on this course 0, this course 1, etc. And if we return false, on that DFS call, then we actually can just return false entirely. Otherwise, if we exit that for loop, it means we didn't return false, so we can just return true, because that would mean we can that means we can actually take all the courses. Now here's where we actually call the DFS function. So we're gonna say if not DFS, what is my input? Course graph visited processed. Course graph visited processed. Okay, if I have any errors. 17, that I'm using Python. Well, it should be insert, not add. Okay, so it looks like it ran okay. Let's submit. Yeah. This code's a little bit like more verbose, right? Because like it is C++, not Python, so you got to be a little bit more strict with your syntax. I think this code looks a lot more complicated than it actually is. It's really not that complicated. I'll be honest, if this problem is confusing to you, I recommend solving this in Python first. Like, and then try it in C++. It'll make more sense because C++ is a little bit more strict, obviously. So yeah, we're setting up our DFS function up here, right? And then, right, remember the steps I showed you, right? Set up the adjacency list with the hash map, right, which is what we're doing right here. And then step 2 is set up the visited and process set, although I did that up here, so I technically did this first. And then set up the hash map here, or create the hash map here, right? This is just an edge case. We don't have to worry about that. I don't want to list that as a step. So we built the adjacency list. We set up the processed and visited sets, as well as the actual hash map creation. And here we're basically running DFS on all the courses that we have, okay? And if we return false for the DFS call, it means there's a cycle somewhere in our graph. Otherwise, if we exit the for loop, it means we didn't find any cycles or anything. So we can actually just return true because we can finish all the courses, right? So yeah. Sorry if this video is a little bit too long, but I really do think it's worth explaining things in detail in this problem, because I think there are a few videos on this problem already, but I feel like a lot of those videos are pretty short. It's kind of hard to understand this problem when they just kind of gloss over stuff and go fast. But yeah, I think you don't have to use a process set. I think some people have like a visited array and they set the index to either 1 or 0, where 1 is it means we're visiting it right now. 0 is we're done visiting it. So you could technically use 1 if you want. I think you could save a little bit of space doing that, but I find this using 2 sets like this much easier to understand, so that's why I did it that way. And I think it's easier to understand and remember. But yeah, in an interview maybe you'd only want to use 1 instead of 2 sets, but I don't know if an interview would actually care that much. Maybe they would. But anyways, I hope this helped, and I'll see you in the next one. Peace out.